Good morning and welcome to class today. Today we are going to be learning integration. In the course of this class, we are going to seek to understand what integration means. We are going to have a look at the relationship between differentiation and integration. We are going to state the general form of integration of polynomials and learn how to integrate polynomials. We are also going to see the formulas for integration of transcendental functions, and we are going to solve examples on integration of polynomials. So, what is integration? Integration, or the actual definition of integration or integral calculus, is a branch of mathematics which seeks to add slices of a function to find the whole. That means when you have a function, you gather all the points of that function together in order to find out the function. Now, this sounds a bit redundant or a bit cyclical, but that's most likely because this definition, or understanding what this definition means, is way beyond the scope of this class. Integration or integral calculus is a very core aspect of mathematics which is applied a lot in physics and engineering. This is just an introductory class, so we are going to go with the simpler but not very correct definition of integration is the opposite of differentiation. While this is effectively true, because what you do to get to integrate a function is basically like the opposite of what you do to get the derivative of that function, but at its core of its nature, integration is not necessarily the opposite of differentiation. There is very little similarity between them. There is very little relationship between the both of them. So let's go into integration of polynomial functions. Of course, the polynomial function is a function where we have one unknown raised to several powers having different coefficients. For example, it's generally in the form ax raised to power n, or summation of ax raised to power n. So you're either having 2x squared, 3x, x raised to power 5, anything, or when you add things like that together, what you have is a polynomial function. So when you have ax raised to power n, to get your derivative, it's going to be n multiplied by 8, as you multiply the coefficient by the power and then you subtract 1 from the power. So for integration, you are trying to reverse this process. So since you subtracted 1 from here, you add 1 to the power, and this power, the original power before you subtracted 1, you must use it to multiply a, so you're going to divide by the power after adding 1. So while differentiation for y equals to a x raised to power n will give you n a x raised to power n minus 1, integrating it, you have a x raised to power n plus 1 all over n plus 1. Now so of course, as I mentioned, integration is a linear function. So when you have several terms of a polynomial added together or subtracted from each other, you simply integrate all of them independently and add or subtract the integrals in the same manner as the original. So let's solve an example. Let's integrate the function 6x squared minus 2x. Of course, remembering our formula, integral of ax raised to power n is ax raised to power n plus 1 all over n plus 1. So the integral of 6x squared minus 2x dx, of course this is the notation of integration, and we always put the x at the end of the statement. So this is going to be integrating 6x squared separately and integrating 2x separately, the x indicating that we are integrating with respect to x, because it's possible to have more than one unknown. We can have xu or xv, xy. The x tells us that this particular integration is done with respect to x. So if we have 6y, y becomes a constant. So now going to our main integration, here we have 6x 2 plus 1 all over 2 plus 1. And this, the coefficient of the power of x here is going to be 1. So we have 2x, 1 plus 1, all over 1 plus 1, maintaining this minus sign. So we have 6x cubed over 3 minus 2x squared over 2. Of course, 6 will be divided by 3 and 2 divided by 2. Our final term is going to be the integral of 6x squared minus 2x is going to be 2x cubed minus x squared plus c. Now, this is another important term. If you remember that during our differentiation, every constant was eliminated. The derivative of a constant is 0. So every constant that we differentiated became 0 or was eliminated. So when integrating, we always add the arbitrary constant c to take the place of those constants that were destroyed, or those constants that vanished when we differentiated. Now, integration of transcendental functions. A transcendental function is a function that transcends polynomial. We have the trigonometric functions, the exponential and logarithmic functions. Those are examples of transcendental functions. And for the sake of comparison, I put the derivatives and the integrals here. Derivative of sine x is cos x, but the integral is minus cos x. So you can see that in the case of transcendental functions, the integrals are not always exactly the opposite of the derivatives. For example, here we have cos x being minus sine x. So you will think that the derivative of minus sine x will give you cos x. And well, that might be true. So here we have tan x, derivative being sec square x, but the integral being minus ln cos x. This RC is the constant term that we keep adding, the arbitrary constant that we keep adding. So you can see here, you can see the derivatives and the integrals of all these 6 trigonometric functions. However, in the logarithmic functions, we have e of x, derivative and integral being the same thing, and ln x, derivative and integral being the same thing, where we have a equal to a raised to power x, derivative is x log ea, and integral is ax all over ln a plus c. So in logarithmic functions, the rules are a bit different. Also in trigonometric functions, when you have sine square x, cos square x, the rules are a bit different. So we have to learn those ones independently. If you don't know how to integrate them by yourself, if you don't know how to integrate from, let's say, first principle, which you don't know, you will need to learn what is the specific integrals of particular functions. I hope you're able to learn something new today. Here are some practice exercises. So integrate the following functions: 10x raised to the power 4 plus 2x squared minus 3x, 6x raised to the power minus 2, and 9x raised to the power 2 over 5. If you have any questions, feel free to ask me in the comment section below. And remember that to learn mathematics, all you need to do is practice, practice, and more practice. See you soon.